The Chernobyl disaster, a nuclear nightmare. On April 26, 1986, the world watched in horror as news of the Chernobyl disaster spread. It was an unprecedented event that would change the course of nuclear energy forever. The Chernobyl nuclear power plant, located in what is now Ukraine, suffered a catastrophic meltdown. This meltdown was not just a minor incident, it was a full-scale nuclear disaster. Reactor number 4 exploded with such force that it blew the roof off the building, spewing radioactive material into the atmosphere. The explosion was so powerful that it was felt miles away. The disaster sent shockwaves across the globe, highlighting the devastating potential of nuclear accidents. Countries far and wide were affected by the radioactive fallout, which spread across Europe and even reached as far as North America. The explosion was a result of design flaws in the reactor and human error during a safety test. The combination of these factors created a perfect storm that led to one of the most catastrophic events in human history. The immediate aftermath was chaotic. Emergency response teams scrambled to assess the damage and contain the situation, but the scale of the disaster was overwhelming. Firefighters and plant workers heroically fought to contain the blaze and limit the release of radiation. Many of these brave individuals paid the ultimate price, sacrificing their lives to protect others. The disaster forced the evacuation of the nearby city of Pripyat, turning it into a ghost town almost overnight. Today, Pripyat stands as a haunting reminder of the disaster, with its empty streets and abandoned buildings. The Chernobyl disaster remains the worst nuclear accident in history, with long-lasting consequences for human health and the environment. The area around the plant is still highly radioactive, and the impact on human health continues to be felt to this day. The sarcophagus, a temporary solution. In the immediate aftermath of the explosion, a massive effort was undertaken to contain the radioactive debris. Construction workers, under extremely hazardous conditions, built a concrete and steel structure to encase the destroyed reactor. This structure, known as the sarcophagus, was a remarkable feat of engineering built in just 18 months. It was, however, intended as a temporary solution. The sarcophagus was designed to contain the radiation for an estimated 30 years. Over time, concerns grew about the sarcophagus's structural integrity. Cracks appeared in its concrete shell, raising fears of radioactive leaks. It became evident that a more permanent solution was needed to secure the site and protect future generations. The new safe confinement, a modern marvel. To address the limitations of the aging sarcophagus, an ambitious project was conceived, the new safe confinement, or NSC. This structure represented a new era of engineering and international cooperation in nuclear safety. The NSC was designed to be the largest movable land-based structure ever built, a testament to human ingenuity. Its purpose was twofold: to confine the radioactive remains of reactor number 4 and to facilitate its eventual dismantling. The NSC's design resembles a giant arch large enough to enclose the Statue of Liberty. This arch-shaped structure is 108 meters high, 162 meters long, and 257 meters wide, dwarfing the original sarcophagus it now entombs. Engineering a giant design and construction of the NSC. Building the NSC was a monumental undertaking, pushing the boundaries of engineering and construction. The project required meticulous planning and coordination among various teams of experts, each bringing their specialized skills to the table. The arch's immense size and weight presented unique challenges, requiring innovative solutions. Engineers had to devise new methods to handle the massive steel components and ensure the structure's stability throughout the construction process. The NSC's frame consists of massive steel arches clad in a double layer of high-density polyethylene. This material was chosen for its durability and ability to provide a robust barrier against radiation. This cladding acts as a shield, preventing the escape of radiation. It ensures that the environment and the workers are protected from harmful exposure, making the NSC a safe and secure structure. The structure is designed to withstand extreme weather conditions, including tornadoes, earthquakes, and the weight of snow and ice. This resilience is crucial for the long-term stability and safety of the NSC. To avoid exposing workers to high radiation levels inside the old sarcophagus, the NSC was constructed in two halves on a nearby site. This innovative approach minimized the risk to the construction team and allowed for safer assembly. These halves were then carefully joined together and slowly slid over the existing sarcophagus on a system of hydraulic jacks. This precise and controlled movement ensured that the new structure fit perfectly over the old one, providing a seamless and secure enclosure. Section 5. International collaboration funding the NSC. The sheer scale and complexity of the NSC project necessitated international collaboration. The Chernobyl Shelter Fund, managed by the European Bank for Reconstruction and Development, was established to finance the construction. Over 40 countries contributed to the fund, recognizing the global importance of securing the Chernobyl site. The total cost of the NSC reached a staggering €1.5 billion, a testament to the commitment to nuclear safety. The construction itself was a multinational effort, with companies and experts from around the world pooling their expertise. The NSC stands as a symbol of international cooperation in the face of a shared global challenge. Section 6. A shield breached, the 2025 drone strike. In February 2025, an unprecedented event threatened the integrity of the NSC. The new safe confinement, a massive structure built to contain the remnants of the Chernobyl disaster, faced a new kind of threat. A drone of still unknown origin crashed into the structure, causing damage to the cladding. The impact was sudden and unexpected, leaving authorities scrambling to understand the motive and origin of the drone. The incident sent shockwaves through the international community, raising concerns about the vulnerability of the site. News outlets around the world covered the story extensively, highlighting the potential risk to other nuclear facilities. The drone strike created a 6-meter hole in the NSC's outer cladding and damaged equipment and cables. The extent of the damage was significant, prompting immediate action from the authorities to secure the area. While the structural integrity of the arch remained intact, the incident highlighted the need for increased security measures at the Chernobyl site. Engineers and security personnel worked tirelessly to assess and repair the damage. The International Atomic Energy Agency, or IAEA, condemned the attack, emphasizing the importance of maintaining the safety and security of nuclear facilities. They called for international cooperation to prevent such incidents in the future. The incident underscored the ongoing challenges of securing the Chernobyl exclusion zone. It served as a stark reminder of the vulnerabilities that still exist and the need for constant vigilance to protect such critical sites. Section 7. Assessing the damage, impact and response. Following the drone strike, experts rushed to assess the damage and ensure the NSC's continued effectiveness. The immediate concern was the potential release of radiation, but monitoring systems indicated that levels remained within normal parameters. Emergency response teams extinguished a small fire caused by the drone's impact and worked to repair the damaged cladding. The incident prompted a review of security protocols, including the use of drone detection and mitigation systems. The IAEA pledged its continued support to Ukraine in ensuring the safety and security of the Chernobyl site. The drone strike served as a stark reminder of the ongoing need for vigilance and international cooperation in safeguarding nuclear facilities. Section 8. Chernobyl's legacy, a stark reminder. The Chernobyl disaster and the subsequent efforts to contain its consequences serve as a stark reminder of the potential dangers of nuclear power. The disaster highlighted the importance of robust safety protocols, rigorous design standards, and international cooperation in the nuclear industry. The Chernobyl exclusion zone, once a bustling region, remains largely uninhabited due to radioactive contamination. It stands as a testament to the long-lasting impact of nuclear accidents. The lessons learned from Chernobyl have led to improvements in nuclear safety and emergency response procedures worldwide. The NSC, despite the recent drone strike, represents a triumph of human ingenuity and international collaboration. It stands as a symbol of our commitment to containing the legacy of Chernobyl. Section 9. The future of Chernobyl, dismantling and remembrance. The NSC is not a permanent solution, but rather a crucial step towards the eventual dismantling of the destroyed reactor. The structure provides a controlled environment for workers to remotely operate equipment and dismantle the highly radioactive remains. This process is expected to take decades and will require continued international cooperation and funding. The ultimate goal is to transform the Chernobyl site into a safe and environmentally sound condition for future generations. Chernobyl stands as a solemn reminder of the human cost of nuclear accidents. The site is being developed as a memorial to the victims and a center for education and research on the consequences of nuclear disasters.